In this video, we're going to do a second speed problem example. So in this problem, Stella runs for 10 minutes at 8 miles per hour, and it's asking how far will she go. So we're going to use the Gubbs method again, where we have our given, our unknown, our basic equation, and our solution. In this problem, we have two givens: the time that she was running for, represented by t, and how fast she was running, so our speed, 8 miles per hour. And we're asking how far she'll go. So our unknown is our distance. And it says how far in miles. So we always want to make sure that we keep our units with our unknown so we have something to double check back to at the end when we have our answer. The basic equation we're going to use here is the speed equation. So speed equals distance over time. Now you'll notice that here, distance is our unknown, and so we want it to be isolated by itself on one side of the equation. In the equation we have here, speed is isolated. Using algebra, we can multiply both sides by t, or time, because over on this side, time is in the denominator. So if we multiply both sides, this whole thing by t, and this whole side by t, then we get time times speed equals distance. So we've isolated our unknown variable, and we've put our two known variables on the same side of the equation. So now this is the basic equation we will use. It's the same as this equation here, but we have manipulated it to isolate the variable that we want to look for. So we can plug in our values, or our givens, 10 minutes times 8 miles per hour. Now we want to always make sure that the units that we're using are correct. We're noticing here that our time is in minutes, whereas our speed uses hour as the time unit. So we want to make sure that those two match. If our time unit and our time portion of the speed unit is not the same, then our number will be incorrect. So let's convert. So we need to go back to our givens and convert our time from minutes to hours. Now you could convert this into miles per minute, or you can convert your time unit from minutes to hours. We're going to, in this particular example, use the conversion of minutes to hours. So we take our time of 10 minutes and we use our conversion factor of 1 hour over 60 minutes because there are 60 minutes in 1 hour. So we take 10, divide it by 60, and we get 0.17 hours. So what that's saying is that 10 minutes is equal to 0.17 hours. So now we can take this value here, 0.17 hours, because that's the amount of time that she ran, and we can plug that back into our equation here. So 0.17 hours times 8 miles per hour will give us our distance. We just took our time, multiplied it by our speed, and it gave us our distance of 1.36 miles. Again, we want to go back and check that our unit of our end result matches the unit for our unknown that was asked for in the actual question. So it says, how far in miles will she go? Our unknown was distance in miles, and our result was an answer that is a number in miles. So it should be pretty good to go. So our final answer here will be 1.36 miles. What I want you to notice from this problem is that not all speed problems are looking for speed as the unknown. Occasionally we will have questions where we are given speed and another variable and asked to find the third variable in that speed equation. So you need to be able to manipulate the equation like we did here using algebra in order to find the variable that the question is asking for.